Okay, welcome back. I hope 7.5 went pretty well for you guys. And now we're going to go over 7.6, common logarithms. Okay, so common logarithms. These are logarithms with base 10. We kind of talked about this a tiny bit at the beginning of chapter 7, but this is kind of going to go in more depth. And we like logarithms of base 10 because our calculator uses them and they're a lot easier to deal with. So here's just a little picture of where your log keys are going to be on your calculator. I also attached a video of how to use the calculator with log if you can't figure it out. So basically it's pretty simple though. You just hit log, punch in your number, and it evaluates for you. But it's only of base 10, so that's important. All right, so for example, let's use a calculator to evaluate these. So if I enter just log of 5 into my calculator, I'm going to get about 0.699. Okay, so that's as simple as it is when we have these regular logs. And there's always an implied 10 as our base. If there's nothing there, it's always an implied 10 because that's our most common logarithm. So on our calculator, let's try B. If I put in log of 0.3, that's going to give me about a negative 0.522. Okay, so simple as that. So try punching these in on your own, and then you can come back and see if you got the correct answer. All right, so log of 7 is 0.845. Log of 0.5 is about negative 0.301. All right, let's use this in a word problem. So we have the loudness L in decibels of a sound is L equals 10, log of I over M. So I is our intensity of the sound and M is the minimum intensity. The sound of a jet engine can reach a loudness of 125 decibels. How many times the minimum intensity of an audible sound is this if M is defined to be 1? All right, so let's define our variables. We know 125 is our loudness, and we know M is 1, and we want to know what I is. Okay, so we have our equation, L equals 10 times log of I over M. So we'll sub in 125 equals 10 times the log of I, right? Because M is just 1. So now all we have to do is solve. So we divide both sides by 10, and we get 12.5 equals our log of I. And now we can rewrite this using our exponential form that we know. So base, answer, power. So our base is always 10 here, right? If it's not written, it's implied that it's 10. To our power of 12.5 equals I. So 10 to 12.5 is about 3.162 times 10 to the 12th. So we can just keep that as 10 to the 12.5. All right, pretty simple, just using the rules we know to solve this. Okay, so what if we can't rewrite these problems? So for example, when we solve this, you guys know that we can write 8 as 2 to the 3rd equals 2 to the 3x. So 3 equals 3x. So 1 equals x. You guys have been doing that for a long time now. Okay, but what happens when we can't rewrite our number on the side with the same base as this one? Right? There's no way we can write 13 as 2 raised to something. So what do? Well, we take the logarithm of each side. So this is why logarithms are actually really useful. So this might seem kind of weird, but it's actually going to help us a lot. So if we have 4 to the x equals 19, there's no way we can rewrite 19 as 4 to the something. So what we're going to do is just take the log of both sides. Okay, now we just need to use our rules to simplify. I know that this x will come out in front, so x times log of 4 equals log of 19. Divide both sides by log of 4. So x is going to equal log of 19 over log of 4. Now you can just enter that in your calculator because it's a common logarithm with our base 10. So log of 19 divided by log of 4 is going to give us x is going to be about 2.123. And it's as simple as that. See how nice logarithms can be for us? So let's try this checkpoint. Go ahead and do it on your own, pause the video, and then come back and see if you got the right answers. Okay, so again, we're going to take the log of both sides. So log of 3 to the x equals log of 15. That gives us x times log of 3 equals log of 15. Divide both sides by log of 3. And we get x equals log of 15 over log of 3. Now we can just punch that in our calculator. So let's see. Log of 15 divided by log of 3 gives us about 2.464. Same thing here. We get log of 6x equals log of 42. So x equals log of 42 divided by log of 6. We can enter that in our calculator. Log of 42 divided by log of 6 equals about 2.086. So logarithms are really nice because they help us solve these problems that otherwise would not be able to be solved. All right, we're going to step it up a gear with inequalities. So I'm going to do the first one and then you can try the second one. So again, we're going to take the log of both sides. Okay, now these are getting a little trickier because we have more variables and numbers involved. So we need to really be strategic in how we're using our properties of logarithms. So here we can bring 5y to the front and we get log of 3 is that less than, we'll bring y minus 2 to the front and we'll get log of 7. So what we're going to want to do here is isolate our variable y. So in order to do that, we need to get all our y's on one side. First, I'm going to have log of 3 here. I'm going to distribute y and negative 2. So I'll get y log of 7 minus 2 log of 7. Now I want everything with my y on one side, so I'm going to subtract this one. So I'll get 5y of log 3 minus y times log of 7 is less than negative 2 log of 7. Okay. So see if you can follow along with these steps here. We're just using our properties and we're trying to get y on the same side. Now this is going to be convenient for me because I can factor out these y's. So if I factor the y's out of both sides, I'll be left with 5 times log of 3 minus log of 7 is less than negative 2 log of 7. If I can fit it in my screen there. Now I have y alone, so I'm going to divide both sides. So I'll get y is less than negative 2 log of 7 divided by 5 times log of 3 minus log of 7. All right. Now I just have to punch that in my calculator like I have been doing. So that'll take a second here. All right, so that's going to give me that y is about less than negative 1.0972. And that's my final answer. So again, all I'm doing is taking the log of both sides here. Okay, and then I'm using my rules of logarithm properties to factor these out so that I can solve for y. So I'm going to distribute here. I put everything with y on the left side. I factor out my y, and I divide both sides by what else I had. All right, try the next one on your own. Pause the video, and then come back and see if you got the right answer. All right, let's see how you did. So we take the log of both sides. Log of 4y is less than log of 5 to the 2y plus 1. Use our properties of logs, so we get y times log of 4 is less than 2y plus 1 times log of 5. Distribute on the right side. So we get 2y log of 5 plus log of 5 by distributing here. Then we want to put everything with our y on one side. So we get y log of 4 minus 2y log of 5 is less than log of 5. All right, factor out your y. Get log of 4 minus 2 log of 5 is less than log of 5. All right, so now another way to do this is we can evaluate this and then divide log 5 of whatever that was. So we'll have y. Let's figure out what log 4 minus 2 log of 5 is. Okay, that's about negative 0.79 is less than log of 5. So now we have to divide. We're dividing by a negative, so we flip our sign. We get log of 5 over negative 0.79. Plug that in our calculator. We get y is greater than about negative 0.8782. Okay, so that's how these logs can get tricky with the inequalities, because if we have a negative on one side like we did here and divide, we're going to have to flip that inequality sign. So it might be a better idea if you're dividing or multiplying to double check and make sure it's not negative. Okay, last part of section 7.6. Change of base formula. So what if we have logs with bases that we don't know how to deal with? Well, we can change that using this formula here. So if we have log a of n, we can write that as log base 10 of n over log base 10 of a. Okay, just like here, we have our log base 3. We don't want to deal with that, so we rewrite it as log base 10 of 11 over log base 10 of 3. So let's try this. We have log base 5 of 140, so I want to rewrite this in common logarithms. So I can write it log base 10 of whatever 140 was, so 140, over log base 10 of whatever my previous base was, 5. So now I just divide log of 140 divided by log of 5. That's going to give me about 3.07. It's simple as that. We just have to remember these little tricks here. Okay, so we're on to our last checkpoint. Go ahead and try that on your own, and then come back and see if you got it correct. All right, so we have a log base 5 of 16. We want to rewrite that with common logs, so we'll have log base 10 of 16 over log base 10 of whatever my previous base was. Plug that into the calculator, get log of 16 divided by log of 5. And that will give me about 1.7227. Perfect. Okay, again, double check your homework on the site because I made it less problems for you. You have a worksheet to do with a partner, and you're done for the day. All right, good work.